today, I'm going to make sure we're actually recording. Here we are. We are working more with integers and fractions today, but with the operations of multiplication and division rather than addition and subtraction. And here's the good news, is that when it comes to multiplication and division, and this is true throughout math, many concepts that we'll cover this year and next year, it's actually easier to multiply and divide things because there are fewer rules you have to remember. Okay, fewer rules you have to remember. And we start with integers here. In the addition and subtraction page, our table was a little bit bigger, a little bit longer. We had more stuff to fill in there because you had to pay attention to, which direction on the number line. You had to pay attention to signs. What does minus and negative mean? What does adding a negative mean? All that sort of stuff. Here, it's a little more cut and dry. All you're looking at are the signs of the numbers, but it's more straightforward. Okay, what is a positive multiplied or divided by a positive? What is the result going to be? A positive. Okay, that's what you grew up learning about. When you first learned your multiplication tables in third grade, it was always just so positive. Okay, when you have a positive multiplied or divided by a negative, the answer is negative. And because you can multiply or divide, well, I shouldn't say that. Because you can multiply in any order, it doesn't matter if that negative sign comes first or second. If one's positive and one's negative, basically if the signs are different, the answer is always going to be negative. Okay? And then kind of like we talked about yesterday, when you've got a double negative, what happens there? Kicks out positive. So general rule of thumb here, if your signs are the same, your product or quotient will be positive. If your signs are different, your product or quotient is going to be negative. Okay? Nothing else changes. 8 times 3 is still 24, but because the 3 is negative, your answer is going to be negative 24. Right? You don't have to worry about which direction on the number line and then add and subtract or whatever else. What operation is it? Really, it's still, you're multiplying, but because one of them is negative, that's what your answer will be. So negative 4 times a negative 5. 4 times 5 is still 20. Is that going to be positive 20 or is it going to be negative 20? Positive 20, because you've got 2 negative signs there, right? There are other ways to show that you're multiplying, and you'll see this more and more. We can use parentheses to show it also, so you don't have to write the operation. That expression there is the same thing as multiplying 10 times 6. Negative 10 times 6, okay? It's still going to be 60, 10 times 6, but because that 10 is negative, it's going to be a negative 60, right? So nothing really changes as far as the operations and what the answers are, except for pay attention to those signs, right? Negative 18 divided by 9. 18 divided by 9 is still 2, but because the first one's negative, it's going to be a negative 2, right? Questions on integers? Did this last year, I would imagine also? Yeah? No? Yeah? Maybe? Maybe remember? Maybe not? Okay? But it all comes down to those signs. This being a key point, this can go on a help sheet for you. Okay? So you still need to know your multiplication facts. You can't use a calculator, obviously, on this part of the test, because I'm not testing whether you can push buttons in the right order. So you do need to know your multiplication facts, but you can put that sign chart on a help sheet if you'd like. Okay? Fractions, it's a similar thing. The rules for multiplying and dividing fractions are fewer than adding and subtracting, because with multiplication, you do not need common denominators. Yay! Right? You do not need common denominators. Same thing with division. So I tell you kind of what the processes are up here. It says to multiply, if necessary, convert mixed numbers to improper fractions. But then here's the key point: multiply straight across. Okay? So the first one, negative 10 ninths times 3 fifths. What sign do you know your answer is going to have anyway? Negative. So once you determine that, you know it's going to be a negative answer. You can kind of ignore that if it messes you up when you're actually doing the multiplication. You know what it's going to do in the end, so as long as you just don't forget that, then you'll be okay. Because now we're going to multiply straight across. 10 times 3? 30. 9 times 5? 45. Are we done? No, because we do need this to be in simplest form. And what's that going to be? What are we going to need to divide by here to put this in simplest form? Simplifying fractions is all about greatest common factor, which, hey, we did that, right? What's the greatest common factor of 30 and 45? 5 is a factor. We'll start there. It happens to not be the greatest one, but we can still use it, right? Divide both 30 and 45 by 5. That gives us 6 and 9. We can go a little bit further. Divide by 3. And that's going to give us our final answer. 6 divided by 3 is 2. 9 divided by 3 is 3. We already have that negative sign out in front. Negative 2/3 is going to be our answer. Okay. Now, what could we have divided by originally to get down to 2/3 in one step rather than 2? Taking 2 is fine. Everyone loves the scenic route, right? But if you wanted to get there lickety split, no. That's for division. Yeah. Yep. Multiplication of multiplying fractions going straight across. But what could we divide? What could we have divided by to simplify 30/45 down to 2/3 in one step rather than take 2? 15. And it's not a coincidence that our two numbers that we ended up dividing by, 5 and 3, multiply to make the 15 that we could have used instead. We didn't, and it's fine, but the option's there. Okay. The next one, 2 and 1/9 times 5/9. What sign will our answer have? What sign? Positive. Okay, so we know that. All right. It does say to convert mixed numbers to improper fractions. What is 2 and 1/9 as an improper fraction? Anthony? 19/9. Remember, 2 times 9 plus 1, right? So 19/9 times 5/9. It's cool we've got common denominators. It's a neat little thing, but it's not required. We can go straight into multiplying straight across. 19 times 5 is 95. 9 times 9 is 81. We think about, can we simplify? Any common factors between 95 and 81? Turns out there aren't. So this would be our final answer. Okay? So you've got the conversion from mixed numbers to improper fractions, which you should do when you add fractions anyway, right? Or can do, I should say. And then multiply straight across. And if necessary, simplify. For division, someone brought up cross products earlier. And that's one of the possible methods for dividing fractions. Let's skip down the page a little bit to 9/10 divided by 8/7. Okay? There are two ways. First of all, convert mixed numbers to improper fractions, just like before. And then your two options are cross products is listed first here. Tell me about cross products. What is that? What is that all about? Or cross multiplication, if that's how you learned the term. Mia? Yeah, multiply the numbers in a cross-like fashion, diagonally. Okay, it's kind of neat because we actually don't divide fractions at all, right? Dividing's no fun. Let's multiply them instead, kind of thing. Okay, so what we're doing here with cross products is we're multiplying diagonally, as Mia said. Okay, 9 times 7 is 63. Where in my answer does that 63 go? Is it going to go in the numerator or the denominator? Well, the position of the number in the first fraction is where that product is going to go. So because the 9 is in the numerator in the first fraction, when we multiply 9 by 7, that 63 is going to be the numerator of my answer. Okay? So it's the position of the number in the first fraction where that product is going to go. Then we multiply the other way. 10 times 8 gives us 80. And look, even makes kind of a multiplication x there, right? And so 63/80ths is our answer. There's nothing that we can do to simplify that, so that would be our final answer, 63/80ths. The other method, one's not easier than the other. It's really just how your brain works here. The other method is to flip that second fraction, and that changes it to a multiplication question. So 9/10 stays the same, but then we flip that second fraction to be 7/8 instead of 8/7. And now we're going to be multiplying these fractions instead of dividing. Flip that second fraction and multiply. And the reason why that works is because now that we're multiplying, we go straight across. So we end up multiplying 9 by 7 anyway, just like we did using cross products. It's the same thing, really. We end up multiplying 10 times 8 anyway, just like we did in the first example. Okay? So we still end up with 63/80ths as an answer. So when I say, it depends on how your brain works. If your brain can, visualize that 9 times 7 diagonally, and you know where to put that 63, that might be easier for you than flipping that second fraction and multiplying straight across. Or if you like that straight across thing, you're more of a linear, okay, your brain might like this method more. Either way is fine, right? They really do the same thing. You're still multiplying 9 by 7 and 10 by 8. Either way, it's just how it's set up, okay? But either way, we get 63/80ths as an answer. Let's look at the next one over. 1 1/8 divided by 2 1/4. First, go ahead and convert those to improper fractions. 1 1/8 and 2 1/4. Convert those to improper fractions. What is 1 1/8 as an improper fraction? Who's got that calculation for us? 9/8, right? 8 times 1 plus 1, 9/8. And how about 2 1/4? What is that as an improper fraction? 9/4. Okay? Now pick a method. See if you can do it on your own. Pick a method and divide those fractions. Are you going to use cross products, or are you going to go straight across? Pick a method and divide those fractions. Are you going with cross products, or are you going straight across? Either way you do it, what does your numerator end up being? Somebody haven't heard from me yet today, perhaps. Either way you do it, cross products or go straight across, flip and go straight across. What does our numerator end up being? Yeah. The numerator is the one up on the top, yes. 36. Okay. If you use cross products, you're multiplying 9 by 4 diagonally there, right? If you flip that second fraction, you end up with 9/8 times 4/9, and you multiply straight across there because now you've written it as multiplication. Either way, you get 36. And then what's our denominator? 72. Okay. In this case, we're not finished because we do need to simplify. And who's got the answer in simplest form here? Who's got the answer in simplest form? Josie? 1/2. Okay, 1/2. Turns out 36 is a factor of 72. It's half of 72. So it simplifies down to 1/2. You could go other routes. The scenic route might be divide by 2 first, and then divide by 6 maybe, and then divide by 2 again, I suppose. 3, actually. Get down to 1/2 that way. Okay. Questions on dividing or multiplying fractions? Isn't it nice not to get those common denominators, though? Right? And like I said, this will be a theme as we move through pre-algebra. It's actually easier to multiply and divide. Even though you learn addition and subtraction first, it's easier to do this. Okay? And the reason why you learn adding and subtracting first is because multiplication is just repeated addition, right? We can't understand what it means to multiply or means to divide without first understanding adding and subtracting. But the rules, there are fewer of them. So for tomorrow, when you come in Google Classroom, there will be a homework check. So this is the one that you will be able to retake it if you don't get a 4 out of 5 the first time. You will need to do it on your own time after school, though. You'll only be able to submit one form tomorrow. And then it's your responsibility to go back and fix whatever you need to fix after that, after school. Okay, so only from PO9 tomorrow, the homework check. Yes, Ryan? Yes, homework is to finish the page. Homework is to finish PO9. Just a one-pager today, right? Oh, there's word problems on the backside. We'll cover those tomorrow. So only the first page of PO9. Only the first page of PO9.
When will bell ringer be posted?
Bell ringer will be posted by, give me till like 7 tonight. Yeah. Yeah. All right, folks, that's iMath. Have a great day, everybody.